Octant, a graphical user interface for Kubernetes. Basically, it's a web-based tool and highly extensible, and you can navigate through Kubernetes cluster for better insights. I think whoever watching this video are familiar with Kubernetes. So basically, if you want to know your Kubernetes cluster information, you need to install a kubectl command line tool on your laptop, and you are going to run several commands to know your cluster info, like a kubectl cluster info, kubectl get pods, get nodes, and many more. So sometimes it's very difficult to remember all those kubectl commands. Then you feel you know if there is some beautiful graphical user interface which will provide all your cluster information, how you feel, so your life will become easier. So that's where Octant come into picture. There are a lot of features available on Octant tool. I have gone through Octant tool by installing Octant on my laptop and running my Kubernetes cluster. I connected it, and there are a lot of features we are going to discuss on this video. Before that, let's know what is the agenda for this particular video I'm going to make. It's the features of Octant, and of course we are going through the Octant website and what are the features available Octant tool, and of course we need to create a Kubernetes cluster, and I'm going to create a Kubernetes cluster on AWS cloud, and install Octant tool on laptop, and I will connect our Kubernetes cluster with Octant tool, and we deploy some apps, and we'll monitor and visualize all the pods and nodes via Octant user interface, by walking through each and every tab that is defined on GUI. And Octant is a tool for developers to understand how applications run on a Kubernetes cluster. It aims to be part of the developer's toolkit for gaining insight and approaching complexity found in Kubernetes. Octant offers a combination of introspective tooling, cluster navigation, and object management, along with a plugin system to further extend its capabilities. The features of Octant tool in the resource viewer. As I said earlier, the graphically visualize relationships between objects in a Kubernetes cluster. The status of individual objects are represented by a color to show workload performance. Easily you can look at all the resources that are running on your Kubernetes cluster. And also we have the summary view, consolidated status and configuration information in a single page aggregated from output typically found using multiple kubectl commands. Usually, to know all this information, you have to run multiple kubectl commands. Kubectl, get pods, get nodes, and so many others like cluster info. And you have to remember so many commands to know your Kubernetes cluster information. So using this Octant graphical user interface, you can seamlessly see all information about your cluster. Port forward, using port forward, you can you can configure local port to the port, and you can see the logs and you can debug it. So usually how you do Java application that is running on remote server, how you can do the port forward and you can debug your application locally. The same way you can do that using Octant tool. Log stream, you can see the logs on user interface, like it will show all the activities, and you can find is there any error in the Kubernetes cluster or pod logs. You can easily trace out if there is any error with your pod. And label filter, using labels you can filter it out, and you can see the pods based on label. So there is a drop down where you can see all the labels, and you can filter it out and you can navigate through. Cluster navigation, there is another tab where you can see all the cluster information, like how many nodes, how many pods are running, like is there any IP address of each node. Before running Octant tool, we must have the running Kubernetes cluster, so that I'm going to deploy our Kubernetes cluster on AWS cloud using Terraform. So Terraform is a tool where you can provision infrastructure as well as Kubernetes cluster, whatever the infrastructure that is required for your organization. Using Terraform scripts, you can deploy. Everything can be automated, and you can deploy all the infrastructure in seamlessly on AWS cloud or Azure cloud. To know more about Terraform, I have made a few videos previous to this video, like what is Terraform and how we can use the Terraform to provision infrastructure on AWS, especially deploying EC2 instances, auto-scaling groups, and Kubernetes cluster using EKS. Yeah, you can go through those videos. If you want those videos links, I'm going to provide in descriptions. Please go through that. And yeah, there is a GitHub repo from my side, how you can use those Terraform scripts. This is my IntelliJ IDE. There you can see that Terraform scripts which are required to provision our Kubernetes cluster on AWS. I have given the GitHub repo of Terraform script in the description. You can go through that and you can follow the instructions are given on a README document how to run these scripts. So basically I'm going to run Terraform command plan. Terraform plan, it shows the plan, like what are the executions are going to be done on AWS cluster, and how many resources are going to provide for our EKS cluster and everything. And you can go through that each and every Terraform script to know more about that. So once we see that, so it's going to create 37 resources as per the plan. So if you see all the information that is available, so it's a complete plan of infrastructure provision. And finally, to provide infrastructure, we need to run Terraform apply and also auto approve. So usually if you don't give the auto approve option, it will ask you whether you want to proceed or not. So we have to type yes and we can proceed, but I would like to give Terraform apply auto approve so that it will provide the required infrastructure like EC2 instances, auto scaling group, and the Kubernetes cluster. So once the cluster is up and running, then we'll see that how we can install the Octant tool on our laptop and how we can connect Octant tool to our AWS cloud and to Kubernetes cluster, so that we can see all the resources and pods that are running on Kubernetes cluster. Basically, in the initial stage, there won't be any pods because we didn't deploy any applications or services on Kubernetes cluster, so that before we see how the empty graphical user interface of Octant look like, once we see the information, then we are going to deploy some sample applications, and also we are going to visualize how horizontal pod auto scaling is going to work once the pods doesn't have enough resources to process the requests. So how each horizontal pod auto scaler can scale up the required pods. So everything can be monitored or visualized via Octant tool. So it's a very powerful. I felt it's very useful tool for Kubernetes developers, especially when you want to visualize and how many pods are running, how many nodes are there, and you want to trace out some logs. So there is a one single point user interface where you can navigate through your Kubernetes cluster. Let's finish this Terraform script and we'll come back. It takes 10 to 15 minutes usually. Then we'll see that how we can install Octant tool on laptop. To install the Octant tool on your laptop, follow the instructions given on Octant website, octant.dev, and follow the instructions. So you can install the Octant tool on Windows, Linux, and even Mac OS. There are different ways of installing, like Windows, Chocolatey, Scoop, Mac OS, the standard installation using a Brew tool. And yeah, it's very simple. Just once you've done that, just you need to run the Octant on from your command line interface like your command prompt or maybe your terminal. Just run the Octant, then it will automatically opens the default browser. So the Octant tool running on 7777 port number on localhost. So once you run this command, you can see that browser is running with the graphical user interface Octant tool. I already installed the Octant tool on my laptop, but now just I want to test how this tool works. Let's see this. So once you install Octant tool on your laptop, just run this. So basically it gives the error because we don't have running Kubernetes cluster currently. We didn't connect our Kubernetes cluster to Octant tool. Basically, to connect to Octant tool to our Kubernetes cluster, once your Kubernetes cluster is up and running, you need to copy the config information of your Kubernetes cluster to our kubectl config, so that Octant tool, once you run the Octant command, obviously Octant tool read the kube config information from your local laptop, and it will try to get all the information, like how to connect to AWS cluster, from there how can connect to Kubernetes cluster, so that it will get the information and it can provide all that cluster information on user interface. So basically you can see some error. It cannot get it, unable to get resources for group kind custom. Yeah, basically we don't have Kubernetes cluster up and running, and there is no information about Kubernetes cluster to this Octant, so obviously it won't show anything. Let's finish our Terraform script to provision our Kubernetes cluster, so that we can come back and we can run the Octant command, and we'll see how it looks like. Now we can see successful provision of Kubernetes cluster on AWS. That is the information that has been given by Terraform script after finishing the execution of all the scripts that are defined here. Basically it shows resources 30 added, 4 changed, destroyed. So the Kubernetes cluster name is Terraform EKS demo. Now we need to get the Kubernetes config information to our kubectl tool. So by running some commands, we are configuring all this information in our kubectl config file, so that we can seamlessly connect AWS cloud and also Kubernetes cluster running on AWS. So I have given all the commands in my GitHub repo. I'm going to provide this link for this GitHub repo in the description, so that you can go through that and you can run those commands. We are also going to see how horizontal pod autoscaler works and how we can monitor HPA on Octant tool. So for that, we need to deploy metrics server to get the metrics into our horizontal pod autoscaler, so that it can provide multiple pods if it is required. And after that, we are going to deploy a sample PHP application, and we are going to ingest more load on PHP application, and the resources that are limited on PHP pod, so that HPA jumps in and it will try to create the new pod. So we are going to see all these details on Octant user interface, and it is and we'll come to know how powerful that tool it is, because to know all this information, you need to run kubectl commands on your laptop on command prompt. Instead of that, how we can see all this information on the Octant tool efficiently. So for that, we have to deploy metrics server before, and I have already the deployment file on my IDE, so that I'm going to deploy that. So kubectl, yes. So this command will ensure that we deploy metrics server, so that using this metrics server, HPA get the pod information about how much CPU is utilized, how much memory is available, how many requests the current pod can handle. So all this information will be fetched to HPA, that is a horizontal pod autoscaler using metric server. That is the purpose of metric server. Now we have it, and we are going to deploy sample PHP application. And before that, we'll see that how Octant tool looks like now, because we have running a Kubernetes cluster now. And let us run Octant command. So this command will ensure that the user interface will be open on our default browser, that is Chrome browser. Now you can see that it shows different tabs here. Yeah, basically now it is showing overview of the Kubernetes cluster. Currently the Kubernetes service is up and running, and the secrets, the default secrets that has been defined as part of our Terraform script, and the current nodes. Yeah, there are starting and registered nodes, so there are 2 registered nodes are, yeah. And you can see from the beginning, if you see, we discussed about features of Octant tool. It shows that we can filter the resources using label. So this is the reference of that. If you see here, use filter by labels. So if you have defined the labels for your resources, so that labels will be shown here on drop down list, and you can choose label and you can view that. And also it has it has a dark mode and light mode option. Yeah, it is very useful nowadays. More people are getting crazy about the dark mode, so obviously they have implemented this as well. And this is the cluster name. See, actually, if you have multiple clusters connected to your local laptop, to your kubectl tool, all those cluster information will be shown here. So you can easily switch between different Kubernetes cluster by choosing a list of cluster names here. So if I choose AWS, it doesn't have anything. This is the EKS cluster that we have deployed using Terraform script, and this is the old one showing pending. I think we didn't deploy any PHP application. Could be the old one, because before making this video I have tested, so it is showing that information, but it doesn't matter, just ignore that. And let us look at cluster overview. Yeah, it shows namespaces section and cluster roles, cluster role bindings, which has been defined by a Terraform script, and currently 2 nodes are running. Those are ready. These are the new nodes created by Terraform script. Those are up and running. And if you see services, there is only one Kubernetes service up and running. Now we are going to deploy PHP application and also service to expose that PHP application to outside world, so that we can send requests to the PHP application and we can see the load, how it is handling. And we are going to limit the resources on each pod. I will show you in few moments. If you go to my GitHub repo, there is a command how we can deploy PHP application. This is the command, just copy it and Control C. So deployment is done. Now you can see that information here. Yes, this is the PHP application deployment that we have done. You can see the pod also. See, this is the pod. Still it is in pending status. It's creating actually, so it will take some time. And also if you see, look at services, it's have only one service, that is Kubernetes service. And we have to limit the resources on pod. What we'll do, right, there is a command which will modify the existing PHP application and redeploys, so that here you can see that we are limiting the resources into 200 microns as CPU. So it can handle 200 microns of CPU drive. So if it crosses more than this, obviously the HPA, horizontal pod scaler, jumps in and it will try to create the new pod for us. And we are going to do that. First, modify the existing application by running this command. Copy it. So if you see the pods, the old one will be terminated and the new one will be created. And we are going to create the service on top of this application using this command. We have seen only one service currently running, that is Kubernetes on Octant screen. If you see here, services, there is only one service. After running this, after creating the new service of PHP application, we can see the service is created. If you go to Octant screen, yeah, this is the one, it's just created. So it's getting the information about Kubernetes cluster in real time. So we get the real-time information from Kubernetes cluster into our Octant tool so that we can visualize each and everything. And also you can see the deployments on the Apache. So, and if you see, look and see, as per the features defined earlier, and it's now the pod is up and running, we can see the logs of pod as well, each pod that we are going to see. And just I clicked on this pod name. See, now you can see the information about the pod, node name and which node this pod is running, and status information, and the pod IP address, host, initialized 1 minute back, and the container information. So very intuitive. You can see all the information about the pod, volumes, secret names, and also many tabs here. Just look at it, what information it has given, labels, annotations, controlled by this resource viewer. See, this is very beautiful, you know. When you see this pod name here, this pod is how it is linked, how it is connected to other resources on Kubernetes cluster. Basically it is connected to service, PHP service, which is exposed to outside world, and also secrets and replica set and default service account and deployment. So this pod is connected to all these resources, so it is visualizing all the connections between the resources. Really intuitive. And YAML file. So this is the deployment file. Usually using this YAML file you can deploy the pod on different clusters. So yeah, it's very informative. And logs, see the logs, it's very useful. And you can search also, you can filter it by name, container name, yeah. And you can log into the container command prompt, and you can like, you know, if you want to see some information inside the pod, and you can run the commands if you know how to deal with it, and you can do that and delete. So if you want to delete this pod, and easily you can delete that as well. Yeah, it's very intuitive information. And replica sets, see, this is all the information is getting in real time. We don't have any ingresses, I think so. Here nothing. And services that we have seen. Let us get into this, what it shows about service. Maybe it will show the same details like metadata. Yes, resource view, beautiful. Yep. And if you go to cluster, yeah, all the information is shown here is, I think it's really beautiful tool, and you no need to run any kubectl commands, and everything is available on one screen. And yeah, it will make your life easier if you are using this tool on your real-time projects. And I don't know how reliable it is, but it maybe if you use regularly you will come to know. Maybe it's a very new tool, definitely there will be some issues. I don't know, but yeah, but this is really very good tool to monitor your production servers or production Kubernetes cluster. And we'll see that how the pod information will be given here. I'm going to put more load on PHP application, and also we have to deploy the horizontal pod autoscaler. So how we do that? I have the command how we can deploy per horizontal pod autoscaler. Yeah, this is the command, because we are giving the limits. Once the pod CPU percentage is more than 20%, and just create the new pod, and minimum is 1, minimum pod can be 1 pod can run always, and maximum, so this horizontal pod scaler can create maximum 20 pods, not more than that. So what happens if there is no much load on PHP application, and there is no space on available nodes, what it will be done? I already deployed the cluster autoscaler, so when there is no nodes available to create new pods, then cluster autoscaler jumps in and it will create the new node for the new pods. So obviously the new pods will be deployed on the new node, and we are going to see that how it is going to be done. And let me deploy the horizontal pod scaler using this command. Yeah, horizontal pod autoscaler is deployed, and we can see this horizontal pod autoscaler as part of I have seen here. See, horizontal pod autoscaler. So this is the command that we have again. So it will, once the pod resources crosses 20%, and it will create the new pod, and minimum pods 1 and maximum 20 we have given. Replica 1, that is current replica, there is only one pod is running. It's just 40 seconds back it has been created. Now we are going to put more load on PHP application by running some commands. Those commands already given on GitHub repo. So this is the load generator image that we are trying to fetch via this command and deploy. Something wrong. Delete this, something wrong. Cd Control C. Let's run it on I'm just running on terminal window, and there is one more command which will loop through the requests continuously. So now this application is continuously sending requests to the PHP application, and we can monitor this on Octant tool, and we can look at horizontal pod autoscaler, and it is fetching the information, and you can see that the percentage of load, obviously after some time it crosses the 20%, and the horizontal pod autoscaler try to create the new pod and deploys it on a Kubernetes cluster. Now we have pods, the load generator, that is the application which is generating requests and sending it to our see the new pods are creating because the percentage resource crossed, it's a 470%. Obviously it's more than 20%. And replicas now it's showing 1, but maybe it shows more. 4 now. Yeah, see, it's getting the replicas information in real time, and pods are creating. All are running, some are pending. So basically now the horizontal pod scaler can create maximum 20 pods. So whenever cluster autoscaler sees there are more than 2 or 3 pods in pending status, then it will realize that there is no enough nodes to deploy those pods, and it will create the new node for our pods. So see how many replicas, 16. So yeah, still 471%. Yeah, so it's 20, so it reached the defined threshold. It cannot create more than 20 pods on existing nodes. What will happen now? We can see that in cluster nodes, see, it's already created the one more node for us, and it is going to create 4, and we can create maximum 5 only, because while creating cluster autoscaler I have given the threshold of it can create maximum 5 nodes, not more than that I can show you on Terraform script. No, it should be there somewhere. Sorry, I think it is in a cluster autoscaler. See here, it can create maximum 5 nodes, not more than that. This is our Terraform cluster name. So by configuring like this, we can limit the nodes creation in autoscaling. So now you can see the maximum it has been created 5 only, and it cannot create more than that. So even you can see how many EC2 instances are running currently. Definitely will be 5, because we have 5 nodes. See, volumes 5 and security groups 5. So this is how we can monitor our Kubernetes cluster using Octant tool. I think this tool is very powerful, and because it's showing all the information that is required for us. Basically you need to run so many kubectl commands to know all this information, and using these tools, just it doesn't require much efforts. Also just install it and run with Octant, only one command. You can get complete cluster information here. So what else you need as a developer to monitor your Kubernetes cluster in production? Very powerful tool. You can try it in your production, and you can put in your comments. I don't know whether there might be many tools, but I found this tool via one blog, and just I tried. Yeah, it's working really good. So if you know any other tool, please put them in comments, and thanks for watching this video. And if you like this video, please like it and share with your friends, and subscribe to my channel. Thank you.